Okay, here we are, Longhorns. This is test 3, the 6th 6 weeks exam review. This is the last test of the 6 weeks and the last test before the final exam. So let's get started. We're going to start with problem number 1. All right, for problem number 1, we are graphing some points on our polar coordinate grid, and we're going to start with point A, which is 4 comma pi over 6. So I'm going to go to pi over 6 angle, and I'm going to go up 4 units. So this is what we're going to do. We count up from the center right here, up 4 units. So 1, 2, 3, 4. And right here is where we're going to put our point to show the point for this polar coordinate. Okay, the next one is at 135 degrees. So 1, 2, 3, that would be about right here. 135 degrees is at 3 pi over 4. And then we have 5 pi over 4. So at 5 pi over 4, we're going to just go up 1 unit. So that would be about right here. And then on the next one, at 330 degrees, that's at 7 pi over 4. So on 7 pi over 4, we're going to go up 5. 1, 2, 3, 4, 5. Puts us right there. Oops. Okay. Okay. And the last one is 0 pi over 3. So pi over 3 is up here. Okay, so we're at 0. So basically, we're going to be right here in the center. And we have 0 radius, which means we didn't go anywhere from the center of the pole. So we're just right there at the center. All right, that's all there is to polar graphing, and I'm going to go ahead and expand these other problems a little bit larger so that we can see them better. And we're going to go ahead and go through the rest of these review problems. Okay, in problem 2, we're going to convert the following rectangular coordinates to polar coordinates. So we're going to do problem A first, and then we'll do problem B. So I'm going to write down a formula here that's going to help us find these coordinates. And the thing we need to be careful about when we're going from rectangular to polar is the angle. So we really need to pay attention to where our point is on the coordinate plane. So if I am looking at this point here, we are somewhere in the quadrant 3. So we need to make sure that when we select our angle for this polar coordinate, that we're in the correct quadrant. Okay, so far we have r equals, and we're using our formula for finding the radius, which is r squared equals x squared plus y squared. So we're taking the square root. And so here I have the square root of -2 squared plus -3 squared. So that's just 4 plus 9. 4 plus 9 is 13. So our r value is going to be square root of 13. Now we need to find our angle, and this is where we need to be very careful. If we're in quadrant 1, if your point that you get on your test is in quadrant 1, then it's no problem. Whatever angle you get in your calculator is probably it's going to be the angle in quadrant 1. But if your angle is in some other quadrant, then you might have to make some adjustments to your angle, because the angle that you get from the calculator is actually a reference angle, and that's what happens in this case. But if your points are, your x value and your y value are both positive and you're in quadrant 1, then you really don't have anything to worry about. Or if your value for y over x, when you do the tangent inverse, if your value for y over x is actually on the unit circle, then you can use one of those radian values. Just make sure you're using the correct angle for the quadrant that you're in. When I took the inverse tangent of -3 over -2, the angle that I got from the calculator was 56.3 degrees. Now I know that 56.3 degrees is in quadrant 1, not quadrant 3. So in order to get the right angle that I need to add 180 degrees to that angle that was given to me by the calculator. This is actually called a reference angle. So we're going to add 180 degrees to the reference angle to get the actual angle where this point is located. So the R value is root 13, and the angle theta, or angle measurement in degrees, is 236 degrees. Now on the test you may get an angle that's nice and pretty, and you might get the tangent inverse of, say, root 3 over 3, or tangent inverse of -1/2, or something like that. If you get something like that, a really nice ratio that's actually on your unit circle for tangent, then you can go ahead and use that angle in radians as your answer. All right, for problem B, we have the coordinate -√3, 1, which is in quadrant 2. So we need to be very careful again about the angle when we find the angle. So we're going to use our equation again that we used to find R, which is the square root of x squared plus y squared. So in this case we have -√3 squared. Make sure that when you do this in the calculator that if you use a calculator, that you put this in parentheses because this is a negative. Okay, so we should get a 3 here, plus 1. 3 plus 1 is 4. So the square root of 4 is 2. So the value for R is going to be 2. Now let's take a look at the angle. We're going to use tangent inverse for the angle, and we're going to put y over x. In this case it's 1 over -√3. Well, we have to change this because we can't have, we don't want a root in the denominator. So we change it and we make this equal to -√3 over 3. So I want to look on my unit circle to see where tangent of -1 is -√3 over 3. And there's two places where this happens. One of the places it happens is at 5 pi over 6, and the other one is at 11 pi over 6. But we want the angle that is in quadrant 2 because our point is in quadrant 2. So we're going to pick 5 pi over 6 because 5 pi over 6 is in quadrant 2. Therefore, our polar coordinate for -√3, 1 is going to be 2, 5 pi over 6. All right, now we're going to convert the following polar coordinates to rectangular coordinates, and we're going to use the same 4 formulas that I gave you earlier in the week. I told you to put them on your formula chart so that you would have them handy. So those are the formulas we're going to use to find our rectangular coordinates. All right, so we're going to use x equals 3 cosine pi over 2 and y equals 3 sine pi over 2. So these are the formulas I gave you, so hopefully you wrote them down. R cosine theta and R sine theta. All right, so let's go ahead and simplify this. 3 cosine of pi over 2. Cosine of pi over 2 is 0. 0 times 3 is 0. Therefore, our x value is going to be 0. And then the sine of pi over 2 is 1. 1 times 3 is 3. So my y value is going to be 3. And that's it. All right, in the next problem, problem B, we have root 3 comma pi over 4, which is in quadrant 1. So we use our formula x equals r cosine theta, which would be root 3 cosine pi over 4, and y equals root 3 sine pi over 4. And for pi over 4, sine and cosine have the same value. They're both root 2 over 2. So for x, we get root 3 times root 2 over 2. And for y, we also get 3 times root 2 over 2. So because these values for sine and cosine at pi over 4 are the same, we're going to end up with the same number for x and for y. So our rectangular points are going to be root 6 over 2 comma root 6 over 2. Those would be our rectangular coordinates. All right, so for question 4, we're converting the following polar equation to rectangular, and then we're going to graph it. So the first thing we need to do is rewrite our secant theta to 1 over cosine. So let's go ahead and rewrite that first. All right, so now we have r equals negative 3 times 1 over cosine theta. And what I'm going to do now is I'm going to multiply both sides by cosine theta. All right, so when I do this, what happens here is we multiply both sides by cosine theta, and I multiply this side by cosine theta. And when I do this, I get r cosine theta, which we know from earlier this week that this right here is the same thing as x. So we can replace our cosine theta with x. So our equation is going to be x equals a negative 3. Okay, now that's the equation. Now we need to go over to the graph and graph it. So if you recall from linear equations, that x equals negative 3 is a vertical line. And you should recognize this by now because we've worked with asymptotes and we've worked with all kinds of lines. And we have graphed vertical lines before, so this should not be anything new to you. All right, so here we go. This vertical line is located at negative 3. So we just draw a line straight up and down at negative 3. Now, be careful because your equation might not be a vertical line. Your equation might be a horizontal line, or your equation might be some other shape. So just because we have this vertical line on the review doesn't necessarily mean that your equation on the test is going to be exactly the same. For problem 5, we need to change this equation. This equation is already in polar form, so we're going to change it. So scratch that off your review. We're going to change it to x squared plus y squared equals 9. All right, so we're going to convert this to a polar equation from the rectangular form, and we're going to use the formulas that I gave you. So we know that x squared plus y squared equals r squared. So we're just going to change that x squared plus y squared to r squared. R squared equals 9. And now we just need to simplify and solve for r. So we get r equals 3. So the rectangular form for this, the polar form for this rectangular equation is r equals 3. All right, for the next part, all we have to do is match the graph to its name. And I've listed these names in order that the graphs are in on the review. So what you need to do is make sure that you know which name goes with which graph. That's a rose. That's a lemniscale. That's a limison, cardioid, or heart. This one's a circle. This one's a limison indented loop. This one's a limison inner loop. And this one is the spiral of Archimedes. Okay, so basically all you're going to have to do is match the name with its graph. So on your test, these will not be in this order, obviously. They will be all mixed up, and you're going to have to know which graph matches which name. Okay, so for question 7, we need to write the set of parametric equations for the given rectangular equation. So remember what we did before. We're going to use cosine squared t plus sine squared t equals 1. And we're going to convert this rectangular equation into a parametric equation using our Pythagorean identity. All right, so we just write our x plus 1 squared over 4 equals cosine squared t. And we are going to take the square root of both sides, and we get x plus 1 over 2 equals cosine t. And then we just solve for x. So we're going to multiply both sides by 2 and subtract 1. And our x equation is going to be x equals 2 cosine t minus 1. And then we do the same thing for y. And when we do the same steps for y, we get y equals 3 sine t plus 2. For question 8, we eliminate the perimeter and write in the form of a rectangular equation. So we're doing the opposite of what we just did. We're going to solve for cosine t. So x over 5 equals cosine t. And then we're going to square both sides. So we square this, we square that, and again we're using the Pythagorean identity. This is the cosine part of the Pythagorean identity. So we rewrite our x squared over 25 plus, and now we need to do the y part. Divide both sides by 2, we get y equals, or y over 2 equals sine t. Square both sides, and you get y squared over 4, and that equals 1. That's all there is to it. All right, so here we have it again. Our insect colony is growing in such a way that each new generation is 1.25 times larger than the first. Suppose the first generation has 100 insects. So we're given the equation for this. And the first question says, is this a geometric or arithmetic sequence? It is a geometric. And question B says, how many insects will be in the 10th generation? So all we need to do here is plug in the 10 minus 1 as the exponent, and the answer we get for this problem is 15,393. And remember, I don't want any partial insects. So no decimals, just round to the nearest whole insect. Okay, so if you have 12.7 insects, you would write 12, not 13, because that 0.7 of an insect does not make a whole insect. So you need to just drop that off. So just drop off any decimals that you have. After 4 generations, what will the total number, the sum of the insects be? In this case, we're going to be using our sum formula. And we start with n equals 1. And we're going to 4 generations. And we're going to use our equation, which is 100 times 1.75 to the n minus 1. And you type it in just exactly like that. Remember, you go to, in your calculate screen, you're going to go to menu, calculus, sum. And then the boxes, you're going to put these numbers. You're going to put n equals 1 in the bottom. You're going to put your number of generations in the top, and then you're going to put your equation in into the side box. And when we do that, we get 1,117. And remember, just drop the decimals, okay? We don't want any half insects or 3/4 of an insect or, 0.9 of an insect. We want a whole insect, just round down, okay? Just drop the decimal. All right, last question. All right, find the third term of 2x minus 2y to the 7th power. So this is a binomial expansion problem, and we want to find the third term, and we're going to use the formula. Instead of writing all of these terms out, we're going to use the formula that I showed you, okay? And I want you to write it on your formula chart if you don't have it. Practice it a few times. Make sure that you know how to use it. We're going to use this one right here. All right, so this is n choose r. Then we're going to have x to the n minus r and y to the r. R is always one less than the term number. So r is going to equal 3 minus 1. This is really important because I noticed on the last test that you all really didn't know where to start. And so you need to start one number less than the term number. So if we're on the third term, then our value for r is going to be 2. So this is what we're going to do. We're going to do a combination, and our combination is going to consist of our exponent, n. We're going to choose 2. That would be our r. This combination right here is going to give us our coefficient. Then we're going to plug in our variables. The first one is 2x. And this 2x is going to be to the n minus r. So 7 minus 2, that's 5. Then our next term is negative 2y. And now this one's going to be to the r. Well, r is 2. So that's going to be squared. So what you want to do, and you need to check this, make sure that these exponents, 2, 5, add up to this number right here. If they don't add up to this number right here, then you made a mistake and you need to go back and check to see where you made your mistake. This number here needs to be 1 less than the term number. So if this is the third term, then this is going to be 3 minus 1. That's going to be the r value here. So we have 7 choose 2, 2x to the 5th, negative 2y squared. And then we simplify. So in simplifying, we get 7 choose 2 combinations gives me 21. 2 to the 5th power is 32, and negative 2 squared is 4. These three numbers need to be multiplied together. We get 2,688, and our variables are x to the 5th, y squared. And that's the end of the review. There is going to be a bonus question at the end, and the only hint that I'm going to give you is that it's going to be graphing a polar equation. So if you want to practice that, there are several examples in your unit where you can practice graphing polar equations. If you have any questions about graphing polar equations, you can come and see me in tutorials, or you can ask any of the Precal teachers for assistance and just practice a few of those polar equations, and it's really not that difficult. It is not something that we went over in class, So it would be something that you would have to learn on your own, but after all, that is a bonus question. So, good luck, Longhorns. This is the last test of the 6 weeks, the last test of the year, other than the final, and I wish you lots of luck, and I hope you do really, really well on this test so you can earn your exemption.